One, two, three. Okay, so now we will now move on to the two main parameters which we have used in this study to define to not define, let me write myself, it is to gauge the level of comfort passengers feel on aircrafts. Now this is, of course, this is like a general set of parameters and can be used anywhere. We have used it on an aircraft, but it's applicable anywhere. So let's go over this. These are two parameters, PMV and PPD. PMV is the predicted mean vote and PPD is the predicted percentage of people who are dissatisfied. What are these two? These two are actually empirical parameters which are derived from empirical equations, and these are based on extensive amount of surveys on how much comfort people felt, or what degree of comfort, were they feeling hot, were they feeling cold, or whether dissatisfied, whether satisfied. All these were based on surveys and it's based on real life data. So that is why these things are very, very reliable. And it's also general index and it's being used quite extensively. It was given by a scientist called P.O. Fagner in the 1970s and is based on heat balance and extensive surveys. Now, what have the parameters I've described before, the parameters that goes into a thermal comfort. Now, what are the parameters that are taken into consideration in this? There are two personal parameters and there are four external parameters. The two personal parameters which are unique to the person that you are talking about are two things. One is the metabolic rate, that is how much the person is actually moving, how much the percentage, how much is the person actually generating heat, because if he's running or if he's sitting and all, like I described before. And the second one is the clothing insulation. Now, if you wear a huge amount of clothes, then of course your body will be feeling hotter because you will not be able to expel that heat as easily as you can, if you were wearing less amount of clothes. That's obvious. Okay. And then second, so these two are the person parameters. These are actually dependent on the person himself or herself. Now the remaining four are actually external parameters that the person does not have any control on. First one is the air temperature. What is the temperature of the air? Well, if you take out a simple dry bulb thermometer, that's the dry bulb temperature which you feel outside. The simple thermometer will give you the temperature. But as for the temperature here we're talking about, the second one is the air velocity. Would you feel as comfortable as you are sitting in a nice calm place, or will you be feeling comfortable if you're in the middle of a hurricane? Okay, so we see even the air velocity has an impact on the level of comfort that you'll be feeling. Also, if the air velocity is strong, your body will actually lose heat through convection even faster. You might not even the sweat that you have will quickly be washed away, if I can put it that way. So all this, so it's a heat transfer phenomenon. If you have air that's moving fast, then this also will happen. Okay, now I'll come to mean rain temperature a bit later. Let's go on this one. The fourth one, relative humidity. How much humidity is there in the air around you? If the area is very, very humid and if it's hot as well, then even though your body perspires, you will not be able to get rid of that thing as easily as you can. So okay, so I've gone over a metabolic rate, the clothing insulation, the air temperature, air velocity, and now before going on to mean radiant temperature, let's go on to the relative humidity. Relative humidity is the amount of humidity that's there in the air. Actually, it's not exactly that, but let's take it as a parameter. It's like more or less indicates how much the air can hold. So the air is, if the relative humidity, which is actually as a percentage, if it is very, very close to 100%, there's a lot of moisture in the air. So it will not be willing to take in more moisture as well. So if you're in a place like in the coastal areas, if you're like in Chennai, or if you're in other in the coastal parts of India, like Mumbai, there's a lot of humidity in the air because of the ocean. There's a lot of humidity in the air. So there, even if it is hot, you might perspire. But when you perspire, the droplets from the skin, they will not be able to go into the atmosphere as much as they will be able to go into in a place that was less humid. Okay, so humidity has a role to play on thermal comfort. Like suppose, let's say you're in some place that's very, very dry, like Delhi or Ooty, or in some place where there's not much humidity. If the humidity is low, if it's low, then you can perspire. If you're feeling hot, you can very easily perspire, and the water molecules will just will evaporate and go into air. So that way you'll be able to feel cooler. But that will not happen in coastal areas because it's so humid over there. You will not be able to get rid of heat through perspiration. So humidity has a very important role to play on the thermal comfort that a person feels. Mean radiant temperature is actually another type of temperature that actually takes into account the radiation that a person will be feeling as well. It's basically defined as the temperature that a person who's living in a complete enclosed area in which there's no radiation coming in will feel the same amount of thermal comfort. Now, this is a very complex topic which has been taken in. In our study, we have kept the mean radiant temperature equal to the air temperature, because inside an aircraft we have taken it, we have approximated the environment inside an aircraft that the radiation that comes in from the outside has a very, very negligible effect. So we've taken it equal to the air temperature. I'll be elaborating more on this as we go on, as we move on to the conclusions. I'll explain to you why we have done this, and also explain what are the limitations of doing this, and also explain why this was a reasonable approximation to make. Now, coming to the PMV index. So these are the parameters that goes into defining PMV and PPD. Now coming to PMV itself. PMV itself is like an empirical dimensionless number which varies from 3 to -3. +3 is very, very hot. As you go down to 0, you begin to feel slightly colder. So 0 is neutral, absolute thermal comfort you're feeling. You're not feeling hot, not feeling warm. So 0 is basically neutral. And as you go down, -1, -2, -3, -3 is very, very cold. It's very, very cold. You feel chill. Okay. So these are so this is how just defined. If someone is saying that your PMV is 3, it means very, very hot. It was -6, very cold. Now, the optimum PMV range as recommended by ASHRAE for thermal comfort inside buildings. We'll not be going into that thing now, but just given for some information, it's always recommended to have PMV between 0.5 to -0.5. You see, it's very, very narrow range. Can be either slightly warm or slightly cold. It's centered around the 0 area. So that's what is recommended to keep the PMV as. PPD. PPT is the percentage of people who are dissatisfied. If there's a lesser percentage, that means it's good, more people are satisfied. But if it's higher, it means that more people are dissatisfied, so it is bad. And also, optimum PPD range for indoor applications like buildings is recommended to keep it lesser than 20%. That is the area in which you have to be in if you're designing a building. PPD is different from PMV because PPD takes into account the factor that thermal comfort, like I said before, is not a universal thing. It varies from person to person. So you have to take in the opinion of not just one person, but of a large number of people. So that's what PPD is. It takes into percentage of people. But take a particular group of people, the percentage who will be dissatisfied is given by this. Okay. Can we stop here?